All right. So in this class, we are going to be doing problems involving intersection of a line and a circle. I want you to uh, recall the first chapter when we were doing quadratics. We said that a line, when we had this quadratic curve, we said that the line can either intersect the curve at 2 points, or it can intersect the curve at 1 point, which means that the line is going to be tangent to the circle, or the line and the curve cannot intersect at all. Okay. So we said that when the line is going to intersect the curve at 2 points, we are going to have two intersection points. We said that the roots are going to be real and distinct. When the line was tangent to the circle, we said that the line is going to touch the curve at 1 point. So the discriminant of this equation must be equal to 0, which means that you are going to have real and equal roots. And similarly, we said that when the lines and the curve are not going to intersect, so there are no points of intersection, the roots, when you're going to solve them simultaneously, and the roots of the resulting equation are not going to be real, which means that the discriminant is going to be less than 0. Now, if we extend the same concept on circle, if the line can intersect the circle at two different points, okay? So the line can intersect the circle at two different points. If it intersects at two different points, then to find the point of intersection, you are going to solve the equation of the circle and the line simultaneously. Now, because if you know that the line and the circle are going to intersect at two different points, then when you're going to solve the equation of a line and the equation of a circle, the resulting equation is going to have real and distinct roots. So the discriminant is going to be greater than 0. Okay, the roots are going to be real and distinct, which means that the circle over here, circle and the line are going to intersect at two different points. When the other possibility is that the line is tangent to the circle. If a line is tangent to the circle, then it is going to be intersecting at only 1 point. So when you're going to solve the equation simultaneously, the nature of the roots of the resulting equation is going to be real and equal. There are going to be two equal roots. And for that to happen, the discriminant of the quadratic equation must be equal to 0. Okay, we are going to say 1 point of intersection and the line is tangent to the curve. And when the line is not intersecting the circle at all, when the line is not intersecting the circle, there is no point of intersection. So when we are going to be solving simultaneously the equation of a line and the equation of the curve, the resulting quadratic equation will have no real roots and will have the discriminant less than 0. Okay. So let's look at this example. The line x equals to 3y plus 10 intersects the circle x square plus y square equals to 20 at the points A and B. So to find the point of intersection, we are going to solve the equation simultaneously. If x is equals to 3y plus 10, then substitute x in equation 2, which is the circle equation, x square plus y square equals to 20. In place of x, plug in 3y plus 10, the whole thing square. Expand 3y plus 10, the whole thing square, that is going to be 9y square, 60y plus 100 plus y square equals to 20. Rearrange this equation, 10y square plus 60y plus 80 equals to 0. Now you can divide the equation by 10 and you are going to get y square plus 6y plus 8 equals to 0. You can factorize this equation further. So y is going to be equal to -2 and y is going to be equal to -4. When y has these values, what is the value of x going to be? X was equal to 3y plus 10. So x is going to be -6 plus 10 plus 4. When x is -4, when y is -4, x is going to be 10 minus 12, that is -2. So the points of intersection are the points of intersection are 4 comma -2 and -2 comma -4. Okay, that's your point of intersection. Are you also getting the same coordinates?
Yes, sir. Just let me copy. Yes, sir.
Now the second part says find the equation of the perpendicular bisector of AB and show that it passes through the center of the circle. We need to find the perpendicular bisector of A and B. So if we have the coordinates of A and B, 4 comma -2 and -2 comma -4, we have to find the equation of the perpendicular bisector. Okay, so the perpendicular bisector of A and B. Now that's the scenario. The line was intersecting the circle at point A and B. We need to find the equation of the perpendicular bisector of AB. Now the perpendicular bisector of AB must pass through the midpoint of A and B. So first thing that you need to calculate is the midpoint of AB. Midpoint of AB is going to be x1 plus x2 upon 2, y1 plus y2 upon 2. That's going to be 1 comma -3. Correct?
Yes, sir.
That's the midpoint. Now we are going to first find the gradient of AB using y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So that is 1 upon 3. Okay, that is 1 upon 3. Now, can you tell me what is going to be the gradient of the perpendicular line?
It will be -3.
The gradient of the perpendicular line is going to be -3. Good. Now, using the midpoint and the gradient of the perpendicular line, I am going to find the equation of the perpendicular bisector.
Y minus y1 equals to mx1 minus x2.
Very
Yeah.
good. Okay, find me the simplified equation.
So that is y equals to -3x minus 1 minute, -4. -6, I mean. Y equals to -3x
Yeah,
minus -6.
no, it's y equals to -3x. Okay,
Yes.
that's going to be cancelled out.
Okay.
Okay, now we have the equation of the perpendicular bisector. Now the third part says the perpendicular bisector of AB intersect the circle at points P and Q. Find the exact coordinates of P and Q. Now this perpendicular bisector is intersecting the circle at P and Q. So P and Q are these points where the perpendicular bisector line is going to intersect the circle. Okay. Now, how do you think I should find these intersection points? I have the equation of the circle and I have the equation of the line. Do you agree that I have to solve these two equations simultaneously?
Sir.
Okay. So please solve these two equations simultaneously and get me the coordinates. You're going
So
to
which
solve
two equation?
equation of the circle and equation of the perpendicular bisector. Equation of the
Okay, sir,
circle
give me
is
a
x
minute.
square plus y square equals to 20. And the equation of the perpendicular bisector is this. Solve these two equations simultaneously.
So do we leave the answer in square root?
If it's coming in square root, then leave it in square root.
Sir, I got like x square is equals to 20 divided by -8.
Okay. So here we are going to solve these two equations simultaneously. That's going to be 10x square equals to 20, x square equals to 2, x is plus minus square root 2. When x is plus root 2, when x is plus root 2, okay, y is going to be minus 3 root 2. When x is minus root 2, it's going to be plus 3 root 2. So the points P and
Sir,
Q,
sir, I'm
yes,
confused. How did you get 10x square?
uh, when you are going to substitute y as minus 3x in the circle equation, after getting squared, it's going to be 9x square. This is going to be
Sir,
9x
it will
square.
be negative. It will be negative.
No, beta,
It's
minus
negative
3x, the
3x.
whole thing square. The square of negative 3 is positive 9x square. Okay. The square, you're squaring minus 3x. That should be positive 9x square plus 1x square. That is 10x square. Okay.
Okay.
So x square is equals to 2 and x equals to plus minus root 2. The coordinates of P and Q are root 2 comma negative 3 root 2. And the coordinates of Q can be minus root 2 times 3 root 2.
Understood, sir.
Okay. So we need to show that a line is tangent to the circle. We have been given the equation of a line and the equation of the circle, but in other form, that's okay. But do you agree that it's the equation of a circle?
Yes,
You're going
sir.
to solve this equation simultaneously. So when y is x minus 13, in the second equation, in place of y, you're going to plug in x minus 13. And then simplify this equation. X square minus 26x plus 13 square is, I think, 169.
169.
Yeah. 6 times 13 should be around 78. Yeah. Now that's 2x square. That's minus 28x. 169 minus 78 plus 7 is plus 98 equals to 0. You divide the equation by 2 to simplify this. That's going to be 49. Okay. Now you're going to solve for x. Apply either factorization or quadratic formula, whatever you prefer. The two values of x are the two values of x are 7 and 7. Okay. Do you see that you are getting repeated roots,
Yes.
real and repeated
So
roots?
it's x is equals to 7. So that means they are straight line.
Yeah, no. It means that the line is tangent to the circle at x equals to
Yes.
7. Okay.
Yes, sir.
Okay, that's one way to go about this. The other way is that instead of solving this equation, you apply the discriminant over here. Discriminant is b squared minus 4ac. Calculate the discriminant of this equation. B squared minus 4 times a times c. Are you getting 0? Check it out.
Sir, what?
Check this out. B squared minus 4ac.
Okay. Yes, sir.
Are you getting 0? Now, if the value of b squared minus 4ac 0 is 0, then what can we say? That the line is tangent to the circle or to the curve, any curve. Okay?
Okay, sir.
All right. Noted, have you noted this down?
Later, after the class. Send me the PDF, sir, please.